Good evening, everyone, and welcome to this today's session of Saturday Talk by Shri Anil Popli, sir. Today is going to speak on the product development process. Anil, sir, has currently retired, having worked as an ex-head of program management with Tata Autocom Systems Limited, prior to which he was working with General Motors International for a period of 8 years plus as a director small cars product development quality. He has also worked as a director GMI quality operations for Yupyong Seoul Korea company and also served as the director after sales for General Motors. He has worked initial years of his career as a regional manager sales and after sales with Escorts, DCM Toyota, LML Bajaj Tempo for the long period of 16 years. With having so much experience in the field of product development and all quality processes, we are, sir, eager to look forward to take inputs from you on the subject. Over to you, sir.
Yeah, good evening, everyone. Just before I start, I just give you some update. Just 2-3 days back, I was, scrolling through Instagram and I saw a reel. It really shocked me, that one Rolex watch has been auctioned for $6 million. So being a product person, I know what the raw material costs are. To my calculation, the raw material cost couldn't exceed $1 to $2. Add some machining costs and administrative costs. This would add up to what? $100, $200? So there is some difference between that $6 million and this $200. Where is the catch? Where is this equation wrong? Well, the equation is wrong because Rolex believes in developing niche market watches. This means that they develop one model of only for 50 people or 100 people. The watches are designed for the presidents of the world, not for me and you. Now, when you have a development cost of about $100 million and you have to divide it on 100 customers, one customer has to pay $1 million purely for the development cost, irrespective of the raw material or manufacturing cost. So here you get an idea what is the level of development process and development costs. And all we need to do is, if we cannot contain this development cost, our product will not be marketable. Next slide, please. So in General Motors, I was heading the small car, that is the Chevrolet Beat, and I developed the car for the whole globe. We were working on budgets like $500 million for one car, and our testing cars itself were about 500. Now compare that to our, erstwhile Indian companies. Their budget for development were not even 1/10th or 1/20th, and the testing cars were not even 1/30th or 1/40th. So if we want to develop a good product, the product development process is huge and involves huge costs. So the level of seriousness required at the working level, at the management level, and the involvement of the top management has to be very, very high. Now on this slide, what you see is that when we make a program, the first component we have to do is to make timing chart. When do we want the product and what are the key gates involved, starting from market research, idea generation, concepts to actual design development, ramp ups, and then the production process and final production. So there are various phases. We are not going to go too much into it. But unless this task is done very carefully, and what the chart you are saying is a macro level, a 40,000 feet high macro level chart. This has to go to the micro level chart. And when I say micro level chart, means that if you are attending a wedding function, who is going to plan for the matchstick to light the oven? If that is not part of your development process or in the micro sheet, chances are you may lead to a lot of embarrassment when you need to light the oven. People today have lighters but don't have a matchstick. It would be embarrassing to light with a lighter. Next slide, please. Now, when we say the stakes are so high that it's not an engineering department role, the number of people involved are so many teams are involved, from engineering, from design, from manufacturing engineering, after sales, our supply chain people, our purchase people, that the biggest task is to keep all these departments working on one direction. Each department has their own goals, but someone in the center has to keep all these puppies within the farm. They should not be moving here and there. Everyone should have a single goal, a single day. Next slide. Yeah. So this center role is to be done by a program manager. Depending on the program, he may be a manager, he may be a director, or he may be a vice president. And his key role is to focus on 4 things: cost, quality, value, and timing. And then he has to run them through program planning, his leadership, the financial management, the governance, and finally the execution of the program. Next slide. So broadly, I'll try to cover what are the technicalities in development. On one side, we have the engineering responsibilities, and the other side, we have the manufacturing processes. So the manufacturing processes will be controlled by APQP. We'll discuss a little bit on the engineering. So the first portion is market research. So here, we want all our customers, actual customer, marketing, evaluation agencies, external, internal, and from that, we will generate ideas. Here, an important part which most organizations forget is the lessons learned and the regulations must be placed on table. What went wrong in the previous launches in detail by department. Those have to be tabled so that there is a concrete method visible that those will not happen again. Then comes the concept creation. Once we have that, we have to see whether this concept is feasible. The demands of various departments may be too high, and thus that has to be thought about with the entire organization, the costs involved, the time involved, and then we develop a concept. What are we going to do? Once we know what we are going to do, next we know what are the challenges. And here comes the program must be teamed. Teamed means we want full-time people reporting to the program manager from each department. And that may be huge. Once that is in place, we will develop the master timing chart. The next point, BOM, I'll come to it a little later. The BOM is the most critical role of development, and I'll cover it in the next slides. Then you go to design and development, followed by mule, betas, gammas. Just for your information, these things don't exist today. There is no mules, betas, gammas. These are just one language prototype. Most big companies, the major functions of a clay model or a beta model, these things are done in virtual. So in the virtual meetings, when these mule and beta gamma level development is happening, all departments are joining that, discussing this in virtual. So this becomes a critical role. The more you can, freeze your requirements in the virtual builds, the less you will be paying in the actual development. Now, based on these, then problems will come up in the virtual, in the actual. We need to develop engineering resolutions, then testing, validation, and then finally engineering release. Engineering release will also discuss a little later that what should the SOR or the statement of requirements contain. If this SOR is very brief, we will have huge problems later. So the engineering release has to be very, very comprehensive for every test which is required, virtual, local testing, at the company testing, at some regulation agency testing, everything should be there. And if there are standards involved, some standards may have to be purchased by the supplier. Some standards might be the organization which we might have to buy or are available on a website. Now, on the other side, when we come to manufacturing, exactly like a timing plan we develop for development, within that, we have to develop the production launch plan. We have to have our standard APQP and PPAP process for supplier and component development. Manufacturing has to plan. And the first task of the manufacturing comes when they have to make a ME build, or the manufacturing engineering needs to build the first car to understand whether the engine will go in the chassis from the top or will it come from the bottom. How will the body get married to the chassis? All these things they have to physically do it with engineering before they can start writing a manufacturing process. So there may be 3 iterations of non-saleable builds. These are to be built and destroyed, and some of these may be taken for testing. Once this is done, our process has to be validated that can a car be assembled properly. So the manufacturing validation has to take place, and the manufacturing produced car has to be retested. Then comes the PPAP or the process for the approval of each part. Then we start the saleable cars production. Here we remove some cars for customer level testing. Customer level means could be some actual customers and could be the quality department other than engineering and manufacturing. Then comes the ramp up stage. Initially, we have to start from 1 car a day and then take it up to 100 cars per day. This will take a month or two. So this ramp up process is pretty long. Then comes feedbacks from the customers, each department. And then the biggest activity is to resolve all the issues before the car can be actually released for sale. Next slide. So whatever we saw in the above the slide prior to this now has to be made into an actual product development process so that we can define what activities can be run in parallel and what activities will run in series. So here the dates of engineering involvement, start of their involvement to each department needs to be clearly defined. And as we go into a bigger product development process, here the individual departments within engineering, their chart also must appear. The more time we spend in building this, the better will be the launch, the less number of problems, and the lower the cost. Next, Bhushan. So this is the standard APQP process. I'm not going to go into detail because I believe that most of people who are in this industry know what the APQP process is. This is a similar level of the chart indicating what the functions of each component will be and where we have to have milestones. Next slide. Now, as I said earlier, that this mules and all are history. Today, 80% of the engineering development has to be done on a computer. The more you do things in virtual engineering, for example, how the engine will go inside the car, everything can be done, and you have to develop your own softwares for which maybe not for a specific program, but they should be generic so that in future also they work. The more you focus on virtual engineering, the more we can contain our costs, because as I said in a Rolex watch, it's unimaginable what the validation or the total development cost they have. And even in General Motors, $500 million is not a small amount. One small mistake may mean that the entire money has to be written off. So in your organization, your engineering should be working on how we will test everything virtually. Yeah, next slide. Okay, I request you to focus on this slide the most, because this will define everything in the development process. Whenever you are going in for a product development process, the first job is to develop a BOM after you have done your research. Now, BOM means bill of material. What are the components which will go together to make this car? I personally would request that you also develop a BOM similar to what I am showing. In this BOM, let's say you are seeing one assembly. Everything you are seeing red is a fresh design. Everything you are seeing green is a carryover. Everything you are seeing yellow is an already validated part with some minor changes. The more reds you have in each assembly, the major the challenge you have. And this slide should be very, very carefully evaluated by the top management, by the vice presidents of each department, and by the working team. And why I am saying we need to have this kind of a chart, everyone in the organization is not an engineer. It's very difficult to explain to each one right up to the team member who's going to develop, assemble the car, that what is new, what is. When he sees things in this kind of a chart, he knows that what is new that I have not handled and what is coming as a carryover which I have handled. The engineering team knows that every green part I don't have to validate individually. Manufacturing knows the green parts I don't have to worry. I have all the jigs, fixtures, everything. I know I can assemble it. So he is very clear that which are the red parts that I have to focus, and he can limit his discussions to that. This drawing, even right up to your CEO, MD, everyone will tell you may have 10, 20 assemblies. When he sees this, you know what the challenge is. Now, in GM, when we were having $500 million, I know I can make 70-80% of these components red. If the top management decided that no, you're going to cut it down to $200 million. Now my work comes straight that 60-70% has to be green. It has to be carry forward. And when I'm talking of this bomb, I'm talking around not about these big assemblies. I'm even talking of fasteners, washers, plastic fasteners, steel nuts, bolts. Everything should be there. In my life, I've seen a simple bolt causing havoc in the validation cycle. And redesigning a bolt at the end is not an easy job. So when you're having carryover parts from a previous model, and if worst come, let's say you don't have this part in your drawer, then the next would be, does Hyundai have this developed? If that is the case, then that's also a good signal. I don't have to validate it all the along, because that supplier has already got it validated by Hyundai. It's not the right process, but it is a comfort level. I hope you've understood this. If there's any question on this, then I'll go to the next. Okay, next slide. So here we've already said that the various milestones have to be developed. I've given what gates we need to keep. And excuse me, this presentation is from a different country, so you'll find words not in English also. So the more we do the breakups, and when we have a milestone meeting, it should be represented by all the vice presidents right up to the CEO. It looks unnecessary, but if the decisions are not taken on time, or the importance of that decision is not understood or passed on to the top people, it could have impact on the program. Next slide. So these are all related to the subcomponents of the development process. I think I've covered most of them. You can refer to them on these slides later. Next slide, please. So as we discussed that everything has to be done virtual in engineering. Similarly, in manufacturing also, everyone has to be involved in a virtual assessment. It shouldn't happen that the actual car has to come for him to understand that this wiring harness cannot go into this hole. If the working persons have already reviewed that, this kind of situations will not happen. So when you are having a manufacturing assessment virtual, your quality guys must be present. Your press shop people should be present. Your body shop people should be present. The guys who are going to assemble the car must be present. So everything in every organization now has to be developed that we can improve our virtual assessment, be it engineering or be it ME, manufacturing engineering, or our entire manufacturing process. And believe me, in my experience, 90% of the issues used to emerge in the virtual assessment. And it helps a lot in, rather than spending so much time on development, redevelopment, it helps us correct it much ahead. For example, if I know that there is a problem and I know it today, I have adequate time to correct it. But if this problem comes to me during the saleable builds or non-saleable builds, I've already lost maybe 1 year or 2 years. Average time for a car development is 5 years. So if someone wakes up 2 years down the line, my risk, costs, challenges are multifold. So when we've gone through this, engineering has to now start preparing for the release of the SOR. What are the components? Engineering now has a clear idea, manufacturing has a clear idea, and they have to start what is the drawings of that product, 3D drawings, 2D drawings, and what are the tests and validation requirements, what are the lessons learned for each component earlier, what aspects the supplier needs to take care, and what are his dates by which he has to supply, how many numbers and all. So if this entire process is done, the draft SOR starts getting made. You don't have to wait for the entire cycle, because the supplier who has to develop the component must know well ahead of the program that what does he need. Next slide. Now when, as I said, you release the SOR and you're going to do some virtual analysis and you're going to do some actual testings also. Engineering has released a draft kind of a SOR, but when we see these components coming, they may have some problem in the marriage between each other or in the design or performance. So at late stages, you need to modify the drawing. And when you modify the drawing, this looks simple, it is not, because here the supplier gets an opportunity to twist your arm and ask for whatever amount you want, because you've already developed 90% with him. For a small change, he might be asking for a totally unreasonable amount, which would you have no other method of ignoring it. You have to give it to him. Next slide. Now we come to validation and testing. Despite that we've done a lot of virtual testing, we need to have a lots of validation. And here the volume of the vehicles, how many you're going to select or how many components you're going to select. We need to do component level validations, system level validation, a subsystem level validation, powertrain validation, performance validation, regulatory validation. So all these, we must know what are the total tests required, what is the number of vehicles required or components required, and what is the total timing required. And then we must have adequate time for iterations. If whatever the reports come negative or you have to do changes, that time for iteration must be kept in the next slide. Now, unlike in the previous developments, today a lot has to be done with the active role of the IT department. There is huge data. The data has to be kept secret, and the data must be able to speak to the other system. So for this, depending on the product you're developing, it may be that your IT systems and data formats, etc., everything have to be developed way ahead of the program itself. Last slide, please. So having done all this, starting from the start of the program by engineering to the start of production, it will go through virtual assessments, engineering milestones, and then everything depends on the testing. For example, if you're testing only 5 cars and one component fails, calculate the ppm. That 20% of the components will fail, and I won't even know if any component is failing less than 20%. So selection of the size of testing is very important, and that's why in General Motors they were going to 500 pieces for testing. So this is all about the assessment process and the development process. I'll be open to any questions.
Thanks for accepting our invite, sir. I have a question. You mentioned in the progress that you take almost 5 years to develop for a new product, totally new product, approximately. And you must have come across some situations where within these 5 years, there is a change in the taste of the market or the market demand or some assessments of the market thing. So have you come across such situation, and what is the mitigation for it?
See, your question is good, but these changes, what you are saying need has come, basically points out that your research, what you did, was not adequate or not ahead of time. Like, for example, if the design of the car or the outer shell of the car is already designed, can you really change it just because someone wants a change? There are some things which you cannot change, and some things are which you can change at a cost. Some things cannot be changed even on cost, unless you want to throw the car program out by about 2-3 years. So as I said, in the whole process is that make sure that the stakeholders are involved from day one. And normally my learning is that the stakeholders are least bothered till they see a physical car, and by that time it is already 2 years, 3 years into it, and then they start giving their observations. That's too late. So unless your CEO and MD sits in the meetings, you won't have these people coming and giving their views, and they will come 2 years, 3 years later and say, no, this should have been there. So it really boils down. Every person must, this was a term in General Motors, push everything to the left. And remember this line, push everything to the left in a timing chart. The more you do things on the left, the more successful you will be. If you are going to change things in the right or in the middle, you're going to cause challenges for everyone.
Related question, sir. Thanks for that. The classic cases of Nano and Martis, the smaller cars. Have you got some feedback, or how the market people failed in their prediction, or how it changed?
For For example, the Chevrolet Beat which I developed, I joined in Korea in 2006. And that was a time when that local car was converted into a global program. Now, when I joined, I had a big laugh. What a joke. Why the hell have I come?
Okay.
They've already done the, design of the car. And now they are saying this is the car for India. This is the car for South Africa. This is the car for US.
Okay.
Things which work in Korea don't work in India. So already when I went there, we had missed the boat. And if you think I could have corrected it, many things we could not correct. So in the development process, what we do is that before the program starts, we send requests to all our customer quality departments. Let's say to US, to South Africa, to India quality manager, to everyone. We take their feedback. What do you want in the car? And it's like a sealed document. If you have not given your requirements today and you have a wake up suddenly, a nightmare and you wake up, then it's not unlikely that without stopping the program you will go through.
That we find that in foreign countries there are a lot of cases of car recalls, whereas in India we find these are not that widespread. Like in Tesla, I understand that every car model that has been released has been recalled at some point of time in some country. But why is it so that, is it the regulatory bodies are stronger there than the auto companies, or the auto companies are not legally bound to call a recall when a defect is noticed in their design process? Or what is the difference? Why is it so that we don't find so many recalls in India, except the minor gearbox or something like that? We don't hear of a mass scale recall, which is not possible if the product is being indigenously developed or developed for the first time.
That if I was developing a car and you were developing a car, or let's say an old company like LML was developing a car, the ethics of the organization will be very different. Now, why are you recalling? You are recalling a vehicle to reduce your risk. That ultimately you have to decide whether you want to take it as a warranty or you want to call it in advance so that customer doesn't have a bad experience. So in India, most companies only recall a car when it is a safety failure. Whereas in US or Europe, Japan, they would prefer to recall a vehicle even if they have a slightest view, that the alternate bearing is making noise, and instead that, customers come and get the bearing replaced whenever the noise comes, and they know it that the problem is going to be 40, 50, 60% in the of the cars. It's better to change it well in advance and take the cost. Of course, and then you want to avoid the cost of courts giving you orders or imposing penalties. So now in India, we don't have that level of awareness, and management don't come up front unless it's a safety failure.
Very, very right. But I think with the e-cars coming up, this will be a major cause of concern. Like even we are finding in the two-wheel sector, there have been a lot of cases of automobile fires. So probably with e-cars, this problem will become more compounded, and the legal framework probably has to be strengthened more, at least in e-cars.
Yeah,
you are very right. There are more risks to the consumer.
Yeah. So if these cars and scooters were validated on a larger volume, there was no reason why the company would not have known. And then it is in these management meetings where senior people take a decision ki jane do, chalta hai.
But maybe it doesn't come in paper at all. In companies, this may be talked but not on record. So no one will take the risk that the higher management is solving an inherent defect or inherent problem. So I don't think it will come in paper in Indian context.
No. See, these things, tell me, in my whole life, we've had so many problems which you would note down on a resolution sheet. But when it comes to the decision making, 80% of the decisions are verbal.
Right, that is what I was saying.
To go ahead or to take action. And where it is said to go ahead, please believe me, in 40 years I never put anything on paper.
That is true. Sir, one more question. Like the government of India is pushing heavily for IC engines to be run on ethanol or methanol. So next 5-10 years, this blending is going to increase. So is the automobile indigenous design industry getting geared for this challenge? Because I think 15% may be the norm which will come as the government is trying to push in the next 5 years. So whether the design industry is ready for this challenge, and worldwide whether this has been attempted to increase the ethanol component of petrol.
See, if you know the IC engine, this change of fuel, whether you want 10% or 20% ethanol, or you want it to run on CNG, or you want it to run on natural gas or any damn thing. The basic engine is the same. So what changes? It is the ignition timing, the fuel ratios, and the total heat produced in the engine. Like you might have to change the camshaft also. And otherwise the walls get too hot.
Correct. Cooling system.
So basically when you're talking of a CNG engine versus a petrol engine or a diesel engine, it is the number of components which need to be changed are very few. For example, if you have a petrol car, you can go on the roadside and someone will change it for you to CNG. The other is Maruti is making a CNG car for you. The difference is when the roadside guy changes it, he's changing only the ignition timing. He's not taking care of the cam timing. And he's also not taking care of the valves, which will tend to overheat and burn out. So the life of the engine will change if it is well designed and the components are not too many where you have to work on.
Understood. So it has to be done from the factory itself, fundamentally.
Yeah. So now, for example, you were going for a hydrogen engine. If in a hydrogen engine, it is the reverse of our ICE engine structure. There, instead of an explosion happening, there an implosion is happening. But by and large, if you see, the engineering is similar. So these things may take a year or two for development at a subcomponent level, but they're not very big.